Okay, so let's talk about the fundamental theorem of algebra today. And so it has to do with, let's start with some graphing here. Oops, here we go. Okay, so we've done a little bit of this already, but let's continue with this. It's going to help us with our lesson today to be really good at graphing stuff. So the steps to graph, when you see something like this, you want to factor it first. Well, of course, it's already factored. Plot the zero, so it looks like there's going to be a 0 at -2. So if you set that equal to 0, you'll see there is a 0 at -2. You see from this one, there is a 0 at +1. Find the end behavior. So if you look at that graph, if you were to FOIL this out, there's a negative in front, so I know this is negative. X times x to the second power, so that would be x to the third power. So if you think about the end behavior, if that's your first term, the end behavior is odd, so that's going to be up, down when it's negative and odd, up, down. So from the leftmost point, it's kind of going up. From the rightmost point, it's going down. Next thing you look at is the y-intercept. Oh, that would really help actually. So if you plug in 0, so if x equals 0, define the y-intercept. Just plug in x equals 0. So that would be -2, so that'd be -2 times -1 squared, which is -2 times 1, which is -2. It looks like I'm going to cross somewhere right down there. Find the multiplicity. So each factor is to a certain power here. So when this first factor is to the first power, so it's going to go through at -2 there. And this one is even, so it should bounce because the multiplicity of that factor is even. It's a 2. There's 2 x minus 1s. So when it hits this point, it's going to bounce off the axis, come down, and go through the axis there. So there's your pretty nice graph. Every once in a while, you're going to plot another point. I could plug in -1 there and see, but I've got enough of points in between there. I think I'm good on that one. Let's try those same points, same test here. So it's already factored. The solution would be -4 here. The end behavior is kind of interesting in that it's going to be negative and even. So it's going to be down, down. There's only one point where it crosses the x-axis here. So I guess on the left, it's going to go down. On the right, it's going to go down. We probably have a pretty good graph right there of this. We could probably stop. If you wanted to find the y-intercept, you certainly do that. Plug in 0 for x. You get -16. So it crosses way down there, -16. I think that's a good enough graph to go ahead and keep that. So look at this one. So the solutions are x equals 2. So right here. Solutions are, this one is x equals -2. And this one also is a factor. Remember, that's a factor. Set it equals 0, you get x equals 0. So you actually have 3 different solutions there where it crosses the x-axis. And we already know the y-intercept is 0. We don't have to plug in a value of 0 because the y-intercept is definitely 0 there. So think about the end behavior here. This would be x to the 4th power. X times x squared times x to the 4th. That's going to be up, up. So from the rightmost point, it's going up. From the leftmost point, it's going up. The multiplicity at -2 is even, which means when it hits this -2, it's going to bounce up. It's going to go through. It's going to go through. Something like that. Not a bad idea for this one to plug in a point or two. You could plug in 1, f of 1. Let's see, that would be 1 times 1 plus 2 squared. 1 plus 2 squared times 1 minus 2. So we get 1 times 3 squared is 9. So 1 times 9 is 9 times -1, which is -9. So, wow, it goes a lot further down than I thought. So way down there. I can't even go down far enough. So it's like, that wasn't a good, it goes way down there. And again, you could plug in -1 as well to maybe figure out how high that goes. I have a feeling it's going to go higher than I drew it there. And this one, let's just kind of look at this one. It's kind of an interesting one. Interesting. So it's going to be -3 here, and that's going to be 0. So those are the 2 points. So that's also the y-intercept. The end behavior is going to be x to the 5th power. So that's odd. So it's going to be in positive. So it's going to look like this. At here, it is an even exponent. So at 0, it's going to cross down, look like that. Maybe plug in -2 to get your little better estimate there. Okay, so now we're get to kind of the main part of this lesson, which is finding all the roots. You should see the power of 4 here and think to yourself, okay, there's going to be 4 solutions here of some type. We don't know if they're all going to be real, maybe some will be imaginary. But what I'm recommending for this is to use your calculator to find the nice rational roots. So get your calculator out. We're going to graph this thing. I don't know what it looks like. Maybe like a W. Let's see. X to the 4th plus, oops, x to the power of 4 plus x to the power of 3 minus 7x to the power of 2 minus 9x minus 18. Okay, so it looks like there's 2 pretty nice solutions there. If you use the trace key menu, 5, 1, type in, I don't know, was it 3? There it was. So at 3, it looks like there's a solution. It looks like -3 as well. If you type in those values, you can always trace to them, but it says there's zeros at 3 and -3. So I've got solutions at x equals 3 and x equals -3. It doesn't really matter the order, but we're going to synthetically divide both of those guys out. So let's start with 3. So 3 goes in the box, 1, 1, -7, -9, -18. What's nice is because I see it on the graph, I know that's a solution to this graph. So I get 1, 3, 4, 12. Hopefully this works out. -5, -15, 1, 1, -7, -9, -18. Okay, so let's see what this works out to be. By the way, I'm pretty sure this should be a +5 here. So 3 times 5 is +15. I made a little mistake there. 6. You'll catch your own mistakes because you realize this has to be a remainder of 0 here. The remainder is 0. Now this is where it gets tricky. This is where I want you to really pay attention on this one. So I've already got that one. Now I'm going to do this one. So I'm going to take this one out. And I'm not going to start over. I'm not going to take the original problem. I'm going to take my answer here. So this coefficient here, I'm going to put the box right there. And I'm going to stop my line right at where the remainder is. So that's going to be my new equation. I'll put -3 in the box this time. If you did -3 first, now you want to do your +3. So let's add those up. We get -3, we get 1, -3, 2, -6, 0. So we again get a remainder of 0, which is great, right? That's what we want here. So this is really, that's a constant, that's x squared. So now we've got a new problem. So our quadratic here is x squared plus x plus 2 equals 0, right? We're setting our quadratic equals 0. I don't think that factors. Let's see, 2 and 1 add up to 1. No, not if they're both positive. I can't factor that, right? So if you can't factor it, let's do quadratic formula, because you want to find all the roots. We know 2 of the roots, 3 and -3. We got those rational roots from the graph. Rational roots are really nice, easy to get from the graph. Everything else, irrational roots, imaginary roots, got to get them the old-fashioned way. So let's get the quadratic here. That was our goal to get there, so we should be able to solve this. Opposite of b over 2 times 1. B squared minus 4ac, so 1 minus 4 times 1 times 2. So we get -1/2 plus or minus square root of -7 all over 2. Let's simplify that just a little bit. So those are 2 of your answers, and these are the other 2. So those are all 4 answers for you. So you're going to get 2 nice rational solutions from the graph usually on these problems I give you. And then the other two might be irrational. In this case, they were imaginary. Let's try this one. Let's look at the graph first, right? We've got to get our first two, maybe. I'm hoping there'll be two nice rational solutions for the graph. In fact, I'm almost banking on it. X to the fourth plus 2x to the third minus 4x squared minus 7x minus 2. Whoops. Same problem I had last time. Must have hit the right key. X to the power of 4 plus 2x to the third minus 4x squared minus 7x minus 2. Ooh, wow, so it looks like I've got a bunch of solutions there. Let's see if any of these are nice ones for the graph. Menu 5, 1. That one's nice. It's a 2. Ooh, I don't love that one. 2.62. Well, I like that one. Negative 1. I mean, I'm going to just plot those points just so you can see this. So I plotted all 4 points just by pressing enter when you're in trace mode. But these two, I think, are irrational. One way to show it, if you hover your cursor over there and hit the plus sign in your calculator, it shows more digits. You can see that both of these might be, ooh, that's interesting. So maybe that one's not rounded off. I'm not sure. But that was definitely irrational, it looks like. So let's get two of these nice rational ones for the graph. Oh, I know, this point is not a 0. There it is. Now it's a 0. That's what it was. I was like, wait, this should be, I must have moved the point there for a second. So that's the actual 0. You can see both of those are irrational numbers when you show more digits. You can see these two are really nice rational numbers, 2 and negative 1. So I know I have a solution at 2 and a solution at negative 1. So it doesn't matter which one you divide out first. I'm going to do 2 first. 2 goes in the box. So 1, 2, negative 4, negative 7, negative 2. I'm going to get this. So 2, 4, 8, positive 4, 8, positive 1, 2. Remainder 0. That's what I wanted. And now I'm going to do synthetic division with a negative 1, my second one. So I'm going to put that box right here and take my answer. I'm only drawing over to where the remainder is on the last problem. I'm using those 4 pieces as my, basically we started with x to the fourth. This row right there is x to the third. I want to bring it down to x cubed. That's my goal here. So let's go one more step. So negative 1, 3, negative 3, 1, negative 1. Shoot. That's what you want to see. Remainder of 0, which means this. Is x, and this is x squared. So if I write that out, that's going to be x squared plus 3x plus 1. Set it equal to 0. That's one of our factors. I don't think it factors, so do the quadratic formula. Opposite 3 over 2 times 1 plus or minus square root of b squared is 9 minus 4 times 1 times 1. So we get negative 3 halves plus or minus square root of 5 all over 2. So those are 2 your solutions, and your other 2 are these 2. And again, the fundamental theorem of algebra basically says when you see x to the fourth, you're expecting 4 answers. 1, 2, 3, 4. There are 4 answers for this one. We found them all. We're good to go. Same thing here. I'm expecting 4 answers here. This one's a little tougher just because it doesn't have a constant that could throw some students off when they do synthetic division. So let's do x to the power of 4 minus 2x to the power of 3 plus x second minus 2x. Nice and weird. Menu 5, 1, solution at 0 and 2. So I have solutions at x equals 0 and x equals 2. Usually when I have a solution of x equals 0, what I do is I factor out the x. So I know x is going to be a solution there, so x cubed minus 2x squared plus x minus 2. Now I have kind of a regular old thing to work with. I know this causes my solution x equals 0, so I'm just going to work with what's left over there. I'm not going to use that full. So with this one, I'm just going to take this. So it's going to be 2 goes in the box. And I have 1, -2, 1, -2. Bring it down. That's 2. That's 0, 0, 1, 2. Remainder is 0. That's what I want. This is x. This is x squared. At this point, you're going to probably have to do quadratic formula. Let's see. X squared plus 1 equals 0. Set that equals 0 solve, so x squared equals -1. What do you do to both sides? You're going to take the square root of both sides. Don't forget, plus or minus. And you get x equals plus or minus I. And you got it. So your solutions are these two real solutions and these two imaginary solutions. You have a total of 4 solutions, which should not surprise us. That's your lesson for today.